Yesterday, we worked with corresponding sides of similar polygons to show that they were similar, they were proportional. Today, we're going to talk about that again, and we're going to find the missing sides. So another thing we need to know, another rule, is the angle-angle similarity. And that states that if we have two angles of one triangle, so angle A here, notice the rainbow, is congruent to angle F. That's the marking. So those two angles are the same measure. I also have another angle, angle B. Angle B is also congruent to angle G. So I have two angles of one triangle congruent to two angles of another triangle. If that is true, then the two triangles are similar. Now remember, the symbol for similar is just a squiggly. And the similar, that means that they have the same shape, but they're a different size. Okay, same shape, but a different size. And in order to have that be true, we have to have two angles congruent to two other angles. So first, let's look at a few triangles and determine whether these triangles are similar. So remember what we have to have. We have to have two angles congruent to two other angles. So if I look at my first triangle, GEF, I have one angle that's the same on both triangles, but I need two angles. Well, the other one's not. But let's find angle G. Now remember, in order to find angle G, we have to take the three angles of a triangle that we know add up to 180 degrees, and we're going to subtract the two angles that we know. So we are going to minus 62 and we're going to minus 48 from 180 degrees to find that missing angle right there. So let's go ahead and do that. Get out your calculators and let's calculate by subtracting 62 from 180 and 48 as well. We come up with 70 degrees. So angle G is 70 degrees. So we know that one is 70 and that one is 70. And we already had that angle and that angle. So they are similar because I have two angles. So to write a similarity statement, I would just write that triangle EGF is similar to triangle, okay, which angle matched up with E? So A, because that was both 62 degrees, and then G was 70, so I'll put C next because that one was 70, and B would go there because that one would have to be 48 degrees. So there's my similarity statement, where I put the angle measures that are the same in the same order after writing my little triangle symbol. Let's determine whether these two triangles are similar. And if they are, we'll write a similarity statement. So you'll notice that we have one angle that's the same, which is 47 degrees, but we need two. So let's find this missing angle for R. So once again, I'm going to take 180 degrees and I'm going to subtract the two measures that I know for that triangle, the 46 and the 68. So in my calculator, I'm going to subtract 47 and 68 from 180 degrees, and I get 65 degrees. So angle R is 65 degrees. Well, we know this one's 59, that one's 47. It doesn't look like they're going to be the same, but let's figure out just for fun what angle U is going to be. 180 degrees minus 59 minus 47 will tell us angle U. That gives us 74 degrees. Are those two triangles similar? Nope, we only have one angle that's the same, and we need two because then that would make all three. So this one is not similar. Let's look at example 4. This triangle, is it similar to this triangle? Well, if we look at the picture, I'm going to pull it apart. There's my two triangles. And we can tell by looking at our picture that we have these two angles are both 30 degrees. So that's 30 degrees, and that one's 30 degrees. So we have one angle that's the same. But how many do we need? We need 2. Let's look at our picture carefully. Notice that they both share an angle. Angle A. So that's the same. If I were to pull that angle back here, pull this triangle back here, you'll see that they both use that angle A. So they do have two triangles that are the same. So this one would be yes. They are similar. Let's write our similarity statement. Triangle ABC is similar to triangle, okay, order matters. Let's put A first because that angle is the same for both. Which angle was the same as B? It was D, so that one would go next. And then the last one would be F. There's our similarity statement. There's our triangles. Now we're going to use that information to help us find our missing sides of our triangles. So this is a beach. How deep is the water? 50 feet from the shore. So you'll notice here with my picture, I actually have two triangles. I have a large one, and I have a smaller one that's inside. Now we know they're similar because we have a 90-degree angle here, a 90-degree angle there, but we also have an angle that they share right there. So to look at this picture, I'm going to set up a proportion. So I'm going to take my two triangles and I'm going to pull them apart, put them up here first so we can look at them. So this little tiny one, this side is 8. And this side here is 1. On the larger triangle, this side is 50 because it went, the arrow is showing that it went from there clear to there. And then this side is the side we don't know. We're calling it H for the height. So we're going to figure out how deep the water is 50 feet out. So let's set up a proportion using corresponding parts and the pattern. So corresponding parts, 8 divided by, let's go to the other triangle that has the same corresponding part as 8. So 8 divided by 50 is equal to, okay, let's go back to the triangle we started with. We started with 8, the smaller one, and then we went to the bigger one, so we're going to go back to the smaller one and divide that by its corresponding part, which is H. Okay, now we can solve it for our unknown. Top numerator times denominator, denominator times our numerator, or top times bottom, which is 8H, is equal to bottom times top, which is 50. Okay, let's go ahead and solve that. So we're going to divide by 8 on both sides. So H is going to be equal to 6.25 feet, or 6 1/4. We found it. Our last example for today is talking about how high the ramp is when it is 2 feet from the building. We're going to figure out how high it is. So first off, let's look at our triangle. We know that they're similar. They've given us that hint. And we have this triangle. And we also have another one that's larger. That is this triangle. Now the two triangles are similar. So let's pull it apart and see if we can find H. So let me pull this apart. We'll put, here's our one triangle, here's the other triangle. Okay, now let's fill in the parts so we can look at what's corresponding. Notice this was H right here. So on the smaller triangle, this is H. We know that this great big side here on that big triangle is 20. So this will be 20. We know that the larger triangle has a side right here of 2.5. But we don't have this side here. So let's look at our picture for a minute and see if we can pull some more information from it. So if I look at my picture, notice that the whole entire thing from here to here is 20, but I have this little section right here that they're telling me is 2 feet. But I need this part from there to there so that I can fill it in on this triangle right here. So if you look at your picture, the great big piece is 20, but I need this part gone, and they're telling me that's 20. So I can take the entire piece minus this little tiny part right here, and that's going to give me this side of that triangle. Now I can set up a proportion and find my missing height. Okay, let's set it up. Let's start our pattern. It doesn't matter which one we start with, but we're going to set up a proportion. So if I start with this side and say 2.5 divided by, okay, let's find the corresponding part on the other triangle. It's H. It's the same part. Is equal to, let's go back to the one we started with. We started with this triangle. So my next side, the one that has to be on the top here, is going to be 20. Divided by the corresponding part is this side right here, which is 18. Now we can solve it because we've set it up. So top times bottom. So 2.5 times 18 is 45. And H times 20 is 20H. Now we'll solve it for H by dividing by 20. So the height is going to be 2.25 feet, or 2¼ feet. Our last example for today is talking about shadows. This is a famous question they always put on the ACT test or the SAGE test. Flagpole. Lena is 5½ feet tall and casts an 8-foot shadow. So let's kind of draw a picture to see what we have here. So we have my lovely picture. I'm an artist. There's Lena. We know that she is 5½ feet tall. So 5.5 feet tall. That's how tall she is from there to there. Then she casts a shadow. So the shadow comes along the ground here that is 8 feet. Okay, we're going to have a similar triangle. That's 90 degrees. We've got this here that's similar. We also have at the same time a flagpole that casts a shadow of 48 feet. We don't know the height of the flagpole. So we have these angles. We have similar triangles, so let's set up a proportion. So here we go. I'm going to start with Lena's height. 5.5, that's this side of the triangle. That's the height. Divided by, let's go to the matching or corresponding part of the other triangle. divided by x is going to be equal to, let's go back to the triangle that we started with, 8, the shadow, divided by the shadow. So we went height divided by height equals shadow divided by shadow. Notice that it's the pattern. Let's cross multiply and divide. So 5.5 times 48 is 264 is equal to 8x. We're going to solve it for x, so we're going to get rid of the 8 by division. We always do the inverse operation. It's been multiplied, so we're going to divide. So 264 divided by 8 is 33. So the height of this flagpole is 33 feet.